Right. Good morning. Hope you had how was your weekend? Was it good? Yeah. Okay. That's good news. Right. So for today, sincerely apologize of being slightly late. You all can go to Avenue to Learn. I've posted all these images. Okay. Go to Avenue to Learn to download them. I've just posted them. So today, this is week 6. So our agenda, we're still going to proceed with let me see, absolute motion, analysis, and then we are going to go into relative motion analysis. Okay, so that's what we're going to do. Any one of you, hold on, let me lower the run. Okay. How's the term test? Good. What do you learn? What do you learn from the term test? Say it again. Do your homework and, hey, yeah, do your homework, check over your work. Okay, as long as you do your homework and understand the what? The examples, you'll be fine. Are we clear? I'm not here to trick you out on this. Okay, so most important thing, do your homework, write summary sheet, and then you'll be fine. How many of you left within 1 hour? 2 hours? Stay all the way. Listen, how much are you paying for school fees? A lot of money. Okay, I come from a poor family. When I'm asked to write an exam, I write all the way. All the way means what? To the end. Okay, even though I have the confidence, I sit and do the question again and again and again and again to check. Are we clear? Okay, I was not top in class, by the way. Okay, I was 4th. There's some freaking genius ahead of me. Are we clear? Okay, so you do again and again per course. Those of you who are local, you pay $1,000. Those of you who are foreign, how much do you pay now? Any visa student? $6,000. You get the best out of it. Are you clear? What? 6 grand? I buy you coffee every day. Ridiculous. Right. So if we look on what happened, right? We look at this example, and I did not finish this example yet because it's not that difficult. We just need to integrate another time, or sorry, differentiate another time. So I'm going to start from example number 2. $6,000. Gee. I don't think the course can earn you back 6,000 when you complete it, but anyway, not this one. Okay, 3A is different. Okay, we're going to carry on this problem over here, right? Just quickly recap what we are told to do or to determine is to find the velocity and acceleration of the follower rod at A. Okay, so this is rod A as a function of theta. Okay, so the rules of solving problem like or the procedure of solving problem like this is to ensure what? is to make sure you create a relationship between distance, x, right, as a function of what? Theta, okay? Then from here, you have to identify that this expression over here, just to quickly recap, is theta is a function of time, E and R are constant, okay? So E is an eccentric distance over here. So this is our E. R is our radius, so it's a constant. At this instant, I want you all to determine the velocity. Okay, it did not mention at this instant. So we are going to analyze it at this instant, okay? Why I say at this instant? Because theta can change to in this direction, okay? Can be changed to this value, okay? So we are looking at theta from 0 to 90 degrees. So from here, we found our expression for velocity at A. Next, we are going to determine, okay, we're going to finish off this example. We're going to determine I do beg your pardon, okay, I have this disorder that I need to check every time. Determine the acceleration at point A. Okay, so what we do now is we know that VA is equal to E omega sine theta. And we know from here that omega and theta is time dependent. Okay, and E is a constant. Okay, so from here we know that we are going to differentiate. Okay, and then this will looks like d over dt, and we are going to differentiate minus E omega sine theta. Now, you will ask me why we did E or minus E omega sine theta. Because if we were to look at this expression, originally is minus E, right? Omega sine theta. Okay, this is the original. But for the fact that we know, if you look at the direction of omega, is going in a what? Clockwise direction. When it's clockwise direction, you substitute it, right? You substitute omega is equal to minus omega, or omega, yeah, omega you substitute equal to minus omega because of the clockwise rotation. So the final expression is minus E minus omega sine theta. So this you get E omega sine theta, okay? But when we are going to do differentiation, we start from where? Make sense or don't make sense, right? You go into the original, not wanting to know whether omega is positive or negative initially. Are we clear? So that's why we use minus E omega sine theta, okay? So from here, we start to differentiate. So omega, when you differentiate, you get minus E sine theta, and then you get d omega over dt. Okay. Then you plus, then you minus E omega, you differentiate, you get cos theta, d theta over dt. Okay. So we are aware that d omega over dt is equal to alpha, and we also know that d theta over dt is equal to omega. Okay, so you substitute this into your expression. So d omega, so you get minus E alpha sine theta plus, or now it will be minus, okay, so minus d theta over dt minus E omega cos theta omega. Okay, so this will be equal to minus E alpha sine theta minus E omega squared cos theta. Okay. Now, if we were to look back at the question, okay, if we were to look back at the question, what we can see that they did mention, okay, with a constant angular velocity omega. Okay, so note, I'm going to write on the next page. Okay, note, you still need time to copy over here. Let me know. Okay, take time to copy that. So I help you out later on. So just to be clear, when you integrate, you put this down here, okay? This one is, we have substitute omega equal to minus omega into here. Okay. Right, so when we take the expression, okay, or I'm going to copy the question. So let's be clear, or let me be clear about this. Okay, so from the question, all right, from the question, we are given that omega is a what? Constant. So therefore, alpha is equal to 0. So if we were to look at the expression acceleration at point A is equal to minus E. Okay, so we just differentiate this. Okay. Okay, by stating the above statement, this expression will be equal to what? Will be equal to 0. So therefore, acceleration at point A will be equal to minus E omega squared cos theta. And this is your final answer. Okay. It's not so difficult. The most important thing is the first stage is to relate the distance, okay, with theta. Okay, that's all. Okay, it's not that bad. I hope it's not that bad to you. Right, the next example that I'm going to do is one of the words that you can find in this topic of absolute motion. So example number 1 for today. And I've just posted this question on Avenue to Learn. Is this one, okay? So you can, it's on Avenue to Learn. You can have this figure. Okay? It's good to have the figure around. Right. So again, they highlight that at the instant shown means at this moment. Okay. The disk is rotating with an angular velocity omega. So if we look at omega and alpha, right, they are both what? Positive. No, I do apologize. They are both negative. It's going in the clockwise direction. Okay, both are what? Negative. The disk is rotating with an angular velocity of omega and an angular acceleration of alpha. Determine the velocity and acceleration of the cylinder B at this instant. Okay, so we are going to determine velocity at B, and we are also going to determine the acceleration at point B, and we know that both are going upwards because the disc is rotating in a clockwise direction. Okay. So we are going to neglect the size of the pulley of C. So we are going to mention that radius